Any slides again. So now that we have eroded material and we're putting it in the stream now available to be moved, we can now transport it. Again, transportation is dependent upon discharge. The more the discharge is, the more stuff and the bigger the stuff we can move, all right? Ultimately, discharge and transportation are a function of some other characteristics. Topography is the first one. With topography, basically all we're looking for is how steep is that slope. Consider a slide that kids play on. If the slide is super steep, that kid's going to be a rocket and shoot down that slide real fast. If you're supposed to be at the bottom catching that kid, that kid coming down like a rocket might knock you over. They're being transported pretty quick and carrying a lot of momentum, able to do a lot of work. If that slide is pretty shallow and that poor kid is stuck at the top and is not moving, we've got a lower volume of motion happening because the topography of the slide is gentle. All right. Second element is the type of rock that is going to offer the opportunity of ease of transportation or resistance of transportation. So if there's high resistance, there may be a large volume of debris that the water has to navigate around. Every time that there's more jumble of rocks, if you will, in a stream, the harder it is for that river to move downstream. This is called roughness. The more roughness there is, the more turbulence there is, all right? So that's going to affect how much transportation there is of that water. And when you've got lots of water that is rough, you're going to have placid areas where the water may not move as much over time, and you're going to have areas where it's much more fluid and the water is moving more rapidly. Climate is clearly important to water transportation. If there is very little precipitation that falls, then we're not going to have a high volume of discharge, which means we're not going to move very much water down that stream system. If we are in a very, very wet environment, think the intertropical convergence zone where the water is precipitating daily because of the cloud mass in that zone, then we're going to have a high volume of discharge, which means we should have some pretty significant sized volume laden rivers in that area, right? With climate too, I want you to consider that there are climate periods of seasons. So you're going to have some seasons that are going to have more precipitation and therefore higher discharge, and other seasons where there's low discharge because there is no precipitation or low precipitation happening. So the spring and the falls in Ohio and much of the United States are our high precipitation seasons. Spring is generally higher than fall is, so there's going to be more discharge, more erosion, more transportation occurring during the spring months, a little bit less in the fall, a lower amount in the summer and in the winter time. And now remember, there may be snow falling in the winter time, but it's falling and it's being stored on the surface of the earth. It's not melting very much to enter into a river system. All right. The vegetation, as you know from previous units, is tied directly to climate. So the type of climate is going to dictate what type of vegetation there is. The type of vegetation and the amount of that vegetation may accentuate or limit the amount of water that is moved through a system. Vegetation generally acts as a sponge. It slows water down through flow before it enters into a river. By doing this, it reduces the erosion capacity of that river system. And then finally, human materials that are in streams. First of all, think of things like pillars that are in across rivers for transportation networks, so bridges. think dams, think dikes, think levees, which direct and trap water. And then the incidentals, things like pollution that is put into a river. So, that old rusty car that got pushed into the river back in 1930 as an agent. So we've touched on this already. Transported material we can talk about it in two ways. Competence, how competent is that river? Competence is a measure of how big the material is that we can move down the river. Competence is a function of speed, which is velocity. Velocity is a product of how steep the slope is, how much volume of water, discharge, is coming down the river size, and its roughness. All right. If it's a really rough river, we're not going to transport a whole bunch of stuff. The higher the velocity that's created out of those things, slope, volume, river size, and roughness, will create a higher competency. The higher the competency, the bigger the stuff that can come down the river. So baseline thinking is when you have a flood, you can pick up big stones. When you do not have a flood, you cannot move that stone. Capacity, on the other hand, is the total volume of material, big or small, that can be carried down the river. A nice visual is the old adage of the muddy Mississippi. When you look at the Mississippi, it's not clear. It's carrying a lot of silt and other materials. It's got a high capacity because it's got a lot of force behind it. The smaller the river, the smaller the capacity, the smaller the suspended load in that river, the clearer the river is going to be. So that's why you have clear mountain streams, because the capacity is really low. With transported material then, the stuff that is carried by competence and carried by capacity comes in 4 transportation processes. Does it move as a solution? It's been dissolved and is part of the water itself. Is it carried in suspension? Is it carried as saltation, or is it carried as traction? And I've got a couple of slides to help out with those.